Hello, good morning, everyone. My name is VIDHYA SAGAR. Okay. Now we are going to discuss about the second year P black elements, fifth group elements. In that, we are going to discuss about the preparation of nitric acid. This is a very, very important for theory as well as competitive exam. Now we'll discuss now. Okay? Right. Preparation of nitric acid. Nitric acid we can prepare. Nitric acid we can prepare in the laboratory method. In the laboratory method, sodium nitrate, NaNO3, sodium nitrate. You know what is the name of this compound? This is the Chile saltpeter. This Chile saltpeter is reaction with the sulfuric acid. Is reaction with the sulfuric acid. Okay. But you remember here what you are going to prepare? Nitric acid. Now you are able to see nitric acid. See. From this sulfuric acid which donate the proton, and in the place of sodium just add the proton hydrogen from sulfuric acid. Then you got nitric acid. Then your answer is that HNO3 plus sodium bisulfate, it will be from sodium bisulfate. So this preparation in the laboratory we are able to prepare. Okay. And the second one, industrially how they will prepare the nitric acid. Industrially they will prepare the nitric acid by the Ostwald process. The Ostwald process. Ostwald's process, how they will prepare. Ostwald process to prepare ammonia is required. Ammonia. Okay, here you see 4 moles of ammonia is undergoes air oxidation. 4 moles of ammonia is undergoes air oxidation in the 5 moles of oxygen. In the presence of platinum or rhodium gas. Platinum or rhodium gas. Okay, 500 Kelvin temperature, 9 bar pressure. 500 Kelvin temperature, 9 bar pressure. Okay, then you are going to see 4 moles of nitrogen monoxide plus 6 moles of water. It will be formed. The Ostwald process is the first reaction. Okay, right. Ammonia undergoes air oxidation in the presence of platinum or rhodium gas, 500 Kelvin temperature, 9 bar pressure, then formation of nitrogen monoxide plus 6 moles of water. It will be 45, 46. Easy, you are able to remember now. Okay, now here this nitrogen monoxide, the 2 nitrogen monoxide reaction with oxygen, then formation of nitrogen dioxide. It will be from nitrogen dioxide. Okay, this nitrogen dioxide is undergoes a hydrolysis. Reaction with the water molecule. Then now you are going to see nitric acid. So you are going to prepare nitric acid. In the water molecule, how many hydrogens are there? 2 hydrogen here, no hydrogen. Then 2 moles of nitric acid will be formed. 2 moles of nitric acid plus, okay, 2 moles of nitric acid plus NO. Again, NO it will be formed. This NO, the last byproduct nitrogen monoxide, it will be formed. This NO again we are able to recycle. It means that this NO again we are going to take here again. Reaction with the oxygen, then formation of nitrogen dioxide. The nitrogen dioxide again undergoes hydrolysis, then formation of nitric acid. So it is one type of cyclic process. It will be formed. Okay, so this is the preparation of the nitric acid in Ostwald's process. Where in Ostwald process. Okay, all right. So in this reaction, we prepare the nitric acid. This nitric acid, how much percentage it will become? Only 68% of nitric acid it will become. 68% of nitric acid. The 68% of nitric acid, which is by the dehydration. Dehydration. How can you do some dehydration? By mixing of sulfuric acid, by adding sulfuric acid, undergoes a dehydration, then formation of 98%. 98% nitric acid you are going to prepare. 98%. But you know the important point, in the lab grade, only 68% nitric acid only we are going to use. Whereas in lab grade, only 68% of nitric acid we are going to use. Okay, right. Nitric acid is a colorless liquid. Okay, nitric acid is a colorless liquid. Colorless liquid. Nitric acid is a colorless liquid. Okay, which is readily soluble in water, and it's able to form hydronium ion. It means that, and confirm that it is a very powerful acid. It is, what is that? Very powerful acid. So nitric acid is reaction with water, means dissolved in the water, readily soluble in the water, then formation of hydronium ion, H3O plus hydronium ion will be. And then formation of NO3 minus. This hydronium ion confirms that nitric acid is a powerful acid. And you know that nitric acid is a very powerful oxidizing agent. Very powerful oxidizing agent. Nitric acid is a very powerful oxidizing agent. Oxidize others, itself undergoes reduction, oxidizing agent. Okay, in the gaseous phase, okay, nitric acid, it has planar structure. What is it, you know? Nitric acid, it has planar structure, nitric acid. Whereas in gaseous phase. But you know the important point? Nitric acid reaction with metals as well as non-metals, except, this point important. Nitric acid is reaction with metals as well as non-metals, except platinum as well as iron. These two metals are not reacts with which one? Nitric acid. As well as nitric acid does not react with some other elements like iron. Iron also does not react. Okay, as well as aluminum. Aluminum also not reacts. Once you ask the aluminum, why you are not going to react with nitric acid? Because aluminum says the answer is that around the aluminum oxide layer will be present. Aluminum oxide layer. Due to that oxide layer, aluminum does not react with the nitric acid. As well as iron, aluminum, chromium. Okay, these metals also, chromium as well as nickel also does not react with the nitric acid. Okay, so these are not reacts. So which metals are not reacts with the nitric acid? Once again, you see here Rm. You know what is the meaning of Rm? It's a gold. Rm and platinum. This two does not react with the nitric acid. As well as including that iron, aluminum, chromium, and nickel also does not react with the nitric acid. Then which metals are reaction with the nitric acid? Which metals are going to react? Now see which metals are going to react. Okay, now here see, now here which is reaction with the copper. See, copper, 3 moles of copper reaction with the diluted nitric acid, HNO3. Okay, now see here, diluted 3 moles of copper reaction with 8 moles of HNO3, diluted HNO3. Okay, here you want to understand the difference of the reaction with the diluted and concentration. So that's why every time I'm writing the 4 reactions, see, copper is a reaction with the concentration nitric acid. And it is reaction with the zinc also. Diluted 10 moles of HNO3. And zinc reaction with the concentrated 4 moles of HNO3. Okay. Nitric acid is a reaction with these copper and zinc metals. Then what it will be formed, sir? Here the variation is that dilute and concentration. These two variations are very important. When copper reaction with the diluted, what type of compound it will be formed? When copper reaction with the concentrated HNO3, what type of compound it will be formed? Okay, but you remember, there is a concentrated or diluted nitrate, it will be from nitrate. Now see, here 3 moles of CuNO3 taken to copper nitrate, it will be. Even dilute, even concentrated also, copper nitrate, it will be from CuNO3 taken. Even which is reaction with the zinc in the diluted also, 4 moles of zinc nitrate, it will be formed. ZnNO3 taken to, it will be formed. And zinc reaction with this concentrated also, then formation of here also zinc nitrate, it will be formed. That is concentrated or diluted, nitrates are it will be formed. But the difference is that, where is the difference it will become? The difference is that, now see, when copper is a reaction with the diluted nitric acid, nitrogen monoxide, it will be from NO. Nitrogen. That copper is reaction with the copper nitrate, then it will be from NO2, it will be from NO2. Okay, that is the difference. Now you see, zinc reaction with the diluted nitric acid, here, along with the zinc nitrate, what it will be from, you know? N2O, nitrous acid. What is laughing gas? Laughing gas, it will be found. N2O. What is the name? Nitrous acid. Nitrous acid. Okay. Now you can see this zinc is reaction with the constant HNO3, then formation of 2 moles of NO2 will be found. So where is the difference come? The difference is the reaction with the diluted copper, diluted nitric acid with the copper, and diluted nitric acid with the zinc. Diluted nitric acid with the copper, nitrogen monoxide. Diluted nitric acid with the zinc, then formation of N2O nitrous acid will be found. Okay, with the concentrated NO2 direct. Okay, and then see here how many hydrogens? 8 hydrogen, then here 4 moles of water will be formed. Here 4 hydrogen, 2 moles of water will be formed. And here 10 moles, then 5 moles of water molecule will be formed. So here 4 moles, 2 moles of water molecule will be formed. Okay, this inorganic reaction, don't go for by heart. Just understand the reaction and try to remember what are the products are it will be formed. It's a very easy to remember. Just once you practice and understand reaction, what happening in these reactions. Okay, then you can write many reactions of inorganic. Okay, right. Now it means that this nitric acid is going to reaction with all metals, then formation of these type of compounds. Okay, so I saw on the competitive level one question. Sir, lead reaction with okay, concentrated HNO3, then what it will be formed? See, PB is reaction with concentrated nitric acid. So then what it will be formed, sir? Lead reaction with concentrated nitric acid. That is the 4 moles. You know that when this reaction with the concentrated nitric acid, what is happening? Nitrates are forming. As well as the nitrogen dioxide are forming, as well as water is forming. Same here also. Lead reaction with the concentrated nitric acid, then formation of lead nitrate, PbNO2 taken to plus 2 moles of NO2 plus 2 moles of H2O will be formed. So this is an extra reaction for you. Like that you understand the reaction. Okay, these reactions are, if you understand, if they ask another metal also you are able to write. Okay. Now still now we have discussed nitric acid is reaction with the metals. Then nitric acid reaction with the non-metals. Then what is formed here? Okay, that we'll see now. Okay. Now see, non-metals. Sir, what are non-metals? Is a non-metals are iodine, as well as carbon, SAI, P4. These are the non-metals. These non-metals are reaction with the nitric acid. Then what products are it will be formed, sir? Okay. Now see, iodine is reaction with the 10 moles of HNO3. Carbon is reaction with the 4 moles of HNO3. S8 is reaction with 48 moles of HNO3. P4 is reaction with 20 moles of HNO3. Yes. Okay. So these are non-metals. Iodine, non-metal. Carbon, non-metal. S8, non-metal. P4, non-metals. Just before we are discussing about the nitric acid is reaction with metals. Now nitric acid is going to reaction with the non-metals. When I2 is reaction with the HNO3, the formation of 2 moles of HNO3 will be formed. What is it? 2 moles of HNO3 will be formed. Then after, here how many NO3 are there? Then 10 moles of nitrogen dioxide will be formed. Here you remember the main product is that all non-metals are reacting with nitric acid. NO2 nitrogen dioxide gas it will be formed. So brown color gases are evolved here in these reactions. Brown color gases are evolved in these reactions. Okay, right. See, when carbon reaction with nitric acid, carbon dioxide gas it will be evolved. Then formation of 4 moles of NO2. Okay, now here how many hydrogen? 4 hydrogen. Then 2 moles of water. Here how many hydrogen? 10 hydrogen. 2 consumed. Then formation of 4 moles of water. Okay, now see here, SAI molecule. SAI molecule reaction with the nitric acid. Then formation of sulfuric acid. 8 moles of S2SO4 will be formed, as well as 48 moles of NO will be formed. Then 16 moles of water will be formed. Okay, and the last P4. P4 is a red phosphorus. This red phosphorus is reaction with the nitric acid. Then what it will be formed? 4 moles of H3PO4 it will be formed. H3PO4. How many moles? 4 moles of H3PO4 it will be. Then formation of 20 moles of NO2 plus 4 moles of water it will be formed. So this is the chemical reactivity of the nitric acid towards the non-metals. Tomorrow they will ask, you have to give the answer. SAI reaction with the nitric acid, sir, sulfuric acid, sir. P4 reaction with the nitric acid, sir, orthophosphoric acid, sir, S3PO4. Okay, carbon reaction with the nitric acid, sir, carbon dioxide, sir. Okay, iodine reaction with the nitric acid, HiO3, sir. Okay, iodic acid, HiO3, iodic acid, it will be formed. Okay, so if they raise a question, you are able to give answer or not. Once you verify, you are not. Okay, and see, copper reaction with diluted HNO3, what is answer? Sir, nitrogen monoxide, sir. Copper reaction, zinc reaction with the diluted HNO3, sir, laughing gas, sir, N2 it will be formed, sir. Zinc reaction with the diluted HNO3. Yeah, you are able to give the answer like that. Okay, so this is the chemical properties of nitric acid. Now we are going to discuss about the uses. Actually, sir, what is the uses of this nitric acid? Many uses are there. One by one we'll discuss now. See. Many uses are there. First one, uses of nitric acid. The nitric acid uses. Uses of nitric acid. First one, nitric acid which is used to preparation of the ammonium nitrate. Ammonium nitrates. Ammonium nitrate which is used to preparation of the furtherly fertilizers. Okay, and some nitrates are explosive and they will use it as a pyrotechnics. Some nitrates are, what is it? Explosive. and they are used as pyrotechnics. Pyrotechnics. Used as a pyrotechnics. You know, nitric acid is the mixed with the glycerin. Nitroglycerin also it will be found. This nitroglycerin is also explosive compound. See, to preparation of the nitroglycerin, as well as which is used to preparation of TNT. What is this? No, trinitrotoluene. TNT meaning that trinitrotoluene. Trinitrotoluene. It will be found. Trinitrotoluene. Trinitrotoluene it will be found. It is also explosive compound. Okay, and you know that organic chemistry, benzene reaction with the concentrated HNO3 plus H2SO4, the formation of nitrobenzene means nitric acid, which is used to preparation of the organic nitro compounds. Organic nitro compounds also you can prepare by using nitric acid. Okay, organic nitro compounds also. Yes, and industrial level nitric acid, which is used to very useful industrial level pickling of stainless steel. Pickling of stainless steel. Pickling of stainless steel. And etching the metals. Etching the metals. And as well as very, very powerful oxidizer in a rocket fuel. That's the last use. What is that? You know, nitric acid, which is a very powerful rocket oxidizer in a rocket fuels. Okay, so these are the uses of nitric acid. Nitric acid uses. Okay, so I hope you understand about the nitric acid. And here the important question it will become from these three block elements. Preparation of the nitric acid by Ostwald process. Those three reactions are you remember. Those are very, very important. Okay, now we are going to discuss about the allotropic forms of phosphorus. Allotropic forms of phosphorus. Allotropic forms of phosphorus. See, the allotropic phosphorus, how many allotropic means, what is allotropic means? Means the compound form is molecular formula, in chemical formula same, but there exist in different forms. Like you know, carbon exists in diamond, graphite, as well as Buckminster and fullerene. How the carbon exists in different allotropic form. Here, phosphorus also exhibit the different allotropic forms. So, what are those? Those are white phosphorus, red phosphorus, black phosphorus. Okay, so like this, many three phosphoruses are there here. Now we are going to discuss about the white phosphorus. Okay. White phosphorus. Okay, right. Now we are going to discuss about the white phosphorus. The P4 molecule. Okay. Now here what happened, you know, white phosphorus is a translucent, white waxy solid, white waxy solid, translucent. Translucent means it's look like pear soap. Pear soaps, it look like it's a translucent. Okay, and white waxy solid, waxy means you know that candle is the wax nature. So white color waxy solid is like candle, white waxy solid. Okay, and this white phosphorus is a poisonous. White phosphorus is a, what is it? Poisonous. And this white phosphorus insoluble in water. Insoluble in water. Not soluble in water, but readily soluble in, readily soluble in CS2, carbon disulfide. It is the readily soluble. Where? In carbon disulfide. And you remember this white phosphorus having glows in the dark. Glows in dark. In the dark place it will be glows. The phenomena is called, chemiluminescence. What is it? Chemiluminescence. Chemiluminescence. That is called the chemiluminescence. Glows in the dark. Okay, so right. And some other properties of white phosphorus which exists in the discrete tetrahedral structure. How is it? Discrete tetrahedral structure. Discrete tetrahedral structure. So how was the structure, sir? The structure is look like this. Phosphorus, 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 phosphorus. This is a discrete tetrahedral structure. See, in the discrete tetrahedral structure, all phosphors are bonded by the van der Waals forces. Is that? Van der Waals forces. Where? In phosphorus. And you remember, phosphorus to phosphorus only 60 degree angle and 60 angle is present. 60 degrees angle only. That's why it is bear the large steric strain. You remember. Highly reactive. White phosphorus is a highly reactive and less stable. White phosphorus is a highly reactive and less stable. Okay, so this is the information about the white phosphorus. Okay, and see this white phosphorus in the alkali medium, aqueous alkali medium, it gives the phosphine. Reaction with 3 moles of NaOH and 3 moles of water, then formation of phosphine plus 3 moles of NaH2PO2 will be formed. This is sodium hypophosphite, it will be formed. What is the name of this? Sodium hypophosphite, it will be formed. Sodium hypophosphite, it will be formed. Okay, right. Now see, it means that the white phosphorus is a reaction with aqueous NaOH, aqueous alkali medium, then formation of phosphine plus NaH2PO. And you know that very important point? When you are taking the white phosphorus, okay, when you are taking the white phosphorus that exposed in the air, which is catches the fire. Which is the catches the fire, is a burns, is a catches the fire, and then formation of the white dense fumes. What it will form, sir? Then formation of the white dense fumes it will be formed. Okay, now see. White dense fumes. Now the phosphorus, white phosphorus is the reaction with oxygen. It means that what is that, when white phosphorus exposed in the air oxygen is present. The white phosphorus catches the oxygen and catches the fire. Automatically fire it will become in the air. Then formation of P4O10. White dense fumes are formed. White dense fumes are formed. Okay, so this is the information about the white phosphorus. Now we are going to discuss about the red phosphorus. Okay, right. Okay. Actually, you see here what happened, you know, white phosphorus is heating 573 Kelvin temperature several days. White phosphorus heating 573 Kelvin temperature several days. Okay, here the red phosphorus will be found. Red phosphorus. This red phosphorus is heating at a high pressure, high temperature and pressure. Then black phosphorus will be black phosphorus. That black phosphorus, it gives the alpha black phosphorus as well as beta black phosphorus. Two type of series are it. Sir, alpha black phosphorus, how it will be formed, sir? Alpha black phosphorus is formed by red phosphorus. Red phosphorus heating at 803 Kelvin temperature in a sealed tube. In a sealed tube. Alpha black phosphorus it will be. This beta black phosphorus, how it will be formed, sir? White phosphorus is heating at 473 Kelvin temperature, then beta black phosphorus is formed. Okay, so this is the information you see. White phosphorus heating 573 Kelvin temperature several days. Red phosphorus it will be. Red phosphorus heating at a high temperature and pressure. Black phosphorus it is formed. Black phosphorus it has the two type of series as alpha black phosphorus as well as beta black phosphorus. Alpha black phosphorus, how it will be formed, sir? Red phosphorus heating with the 803 Kelvin temperature in the sealed tube, then formation of alpha black phosphorus. And white phosphorus heating 473 Kelvin temperature, then formation of beta black phosphorus. You remember. Okay, right. Now we are going to discuss about the red phosphorus. Red phosphorus. Sir, what about red phosphorus, sir? Red phosphorus, see, white phosphorus is a poisonous. Red phosphorus is a non-poisonous. There is a white color. It is an iron gray loose color. What is this? This is the iron gray lust. Iron gray color. This is iron gray. It means that you know the Mars color, the planet Mars, same color. Okay, iron gray lust hair, and which is a non-poisonous. Okay, and this red phosphorus insoluble in water as well as carbon disulfide. Insoluble in water and carbon disulfide also insoluble. Carbon disulfide also insoluble. Okay, and it does not gloss. White phosphorus glows, but red phosphorus does not gloss. Okay, means it does not show any chemiluminescence. It does not show. Okay, and remember the important point is that red phosphorus more stable, less reactive. Red phosphorus more stable and less reactive. And discrete, whatever the discrete, it also exists in the discrete tetrahedral shape. Those discrete tetrahedral shapes are arranged in polymeric form. Where? Arranged in the polymeric form. They are arranged in polymeric form. How say? See like this. So this polymers are arranged. So the polymeric bond, these are connected by what is that? Covalent bond. What is that? Connected covalent bond. You remember, this is the information about the red phosphorus. Now we are going to discuss about the alpha black phosphorus as well as beta black phosphorus. Already I told you how can you prepare the alpha black phosphorus. Alpha black phosphorus we can prepare by the red phosphorus is heating 803 Kelvin in the sealed tube we are going to prepare. Okay, And you see, this alpha buffers cannot oxidize in air. What is that, you know? Cannot oxidize in air. It cannot oxidize in air. And you see, this sublimes in air, sublime in air, sublimation, sublime in air. It means evaporates. If you take some amount of alpha sulfur, keep in air, it evaporates, sublimes. And then formation of opaque monoclinic. Okay, and rhombohedral. Opaque monoclinic or rhombohedral structures are repeated. Rhombohedral structure. Yeah, who are alpha black phosphorus. And beta black phosphorus is formed. This is cannot burn up to 673 Kelvin temperature. Up to 673 Kelvin temperature, beta black phosphorus cannot burn. So this is the information about the allotropic forms of phosphorus. Allotropic forms of phosphorus. Okay. Now we are going to discuss about the some revision points we will correct here in this one. See, white phosphorus, white waxy solid is a poisonous. Red phosphorus, iron gray luster, it is non-poisonous. And white phosphorus glows in the dark, red phosphorus does not glow in the dark. White phosphorus insoluble in water but soluble in CH2. Red phosphorus insoluble in water as well as CH2. White phosphorus easily catches the fire. It's born in the air and the formation of white dense fumes, but red phosphorus does not. And white phosphorus glows in the dark, that is called chemiluminescence. Red phosphorus cannot. Okay, the some differences also you remember here. And white phosphorus is less stable, angle strain is a 60. Red phosphorus is a stable, polymeric discrete tetrahedral structures are equally found. And white phosphorus van der Waals forces are present, red phosphorus covalent bonds are present. Okay, so if you understand these differences, tomorrow this fifth group we are going to prepare, finish, and we are going to prepare phosphine, PCl3, PCl. Okay, thank you, bye. End the stream, end.